So, our next topic in Unit 5 is solving simple equations. We'll talk about what to do algebraically, what it looks like graphically, how to find the general solutions with some examples, and then a summary. Algebraically, what we're trying to do is isolate x by taking the inverse sine of both sides. This isolates the x over here because sine and inverse sine are inverses. And then we are asked to find the inverse sine of 0.5. So the inverse sine of 0.5 in radians is pi over 6 in the first quadrant. There's also another answer in the second quadrant, which before we kind of ignored, but now we're going to consider it. At both of those angles, the sine value would be 0.5. Graphically, if we take the sine of x graph and put it into one y equals and 0.5 in another y equals, where they intersect give us our answers. If we find the x value of their intersections, that gives us our answers. So pi over 6 and 5 pi over 6. On the unit circle, we would look for the two angles that had a y value of pi over 6. So it would happen here and here. Pi over 6 and 5 pi over 6. The sine graph shows that there are many solutions because we know that the sine graph is going to continue. We have pi over 6 and 5 pi over 6 as two particular solutions, and something you should notice is that those two answers are supplementary, meaning they add up to pi. But the sine graph repeats itself after 2 pi. So, after pi over 6 and 5 pi over 6, every multiple of 2 pi after that is also a solution. So we take pi over 6 and add on multiples of 2 pi, like 2 pi, 4 pi, 6 pi, 8 pi. You could also subtract. And we're going to add in multiples of 2 pi to 5 pi over 6. The 2 pi comes from the fact that it's the period for the sine graph. So let's do another example. This is one where we're going to use our calculators. Find the values of x between 0 and 2 pi, where sine of x equals 0.6. So I'm going to take the inverse of both sides, which is going to give me x on one side and the inverse sine of 0.6. I'm in radian mode because I'm asked to give my answer between 0 and 2 pi. So check the mode in your calculator, find the inverse sine of 0.6, and we get x is equal to 0.64. That's one solution. That's in the first quadrant. To get the answer in the second quadrant, where sine is also positive, we're going to take this first answer and subtract it from pi. Because the first and second answer will be supplementary. They're going to add up to pi. So you can use a decimal approximation for this. And we get a second answer of 2.5. So those are our two specific answers between 0 and 2 pi. Then we get our general solutions, which would be 0.64 plus 2n pi, and 2.5 plus 2n pi. The n tells us that we're going to be using multiples of 2 pi. The n's would be integers. Here's another example. This one will be on the unit circle, but we're going to be giving it in degrees this time. So we're going to find the inverse cosine of 0.5. Make sure you check the mode in your calculator. We're switching back. And we get an x value of 60. The other solution for cosine, cosine's positive in the first quadrant and the fourth. So this time, they're not supplementary like they were for sine. We're going to subtract our answer from 360. or 2 pi if we were in radians. So 360 minus 60 gives us our second answer of 300. So the general solutions would be 60 plus 360n, or in degrees, and 300 plus 360n. So instead of using 2 pi, or in degrees, we'll say 360. One last example with sine. Find the values between x of x between 0 and 360 for which sine is negative 4. So I'm going to take the inverse sine of negative 4. I'm in degrees. And we get no solution. This is an error. Sine cannot be greater than 1 or less than negative 1. Last example with cosine, but we have an extra step involved. Sorry. I need to first isolate cosine of x. And then take the inverse cosine. And then I can give my general solutions. And I'm in degrees. So x is equal to 180, and that's the only solution, because if I subtract that from 360, I get 180. And then there's our general solution. To summarize, we get our two solutions. You'll find one solution first, and then solve for your second solution. To get the general solutions, we're going to add 2 pi to sines and cosines, but remember that tangent has a period of pi. So you only need to add pi to the solutions you get for tangent.